So in this recording we're going to look at a more complex derivative and integral, and what I've done is I've done the integration already, the differentiation already. Okay, the first step being writing this in terms of its index. Now that's a 5, although you can't see that very clearly perhaps. So our derivative is x cubed minus 4 to the power of 5 on 2. I bring the 5 on 2 down to the front, subtract 1 from the power, so from 5 on 2 I end up with 3 on 2. Multiplying by the derivative and I get this expression. This is the expression here, I've just written it bigger so you can see it. Okay, so now what we have been asked to do is find the integral of that thing, hence. So we're looking for a link between these two things. First thing I'm going to do is rewrite this in terms of just its indices. So I've got x cubed minus 4. Okay, and it's the power of 3 over 2 because it's a root there. So 3 over 2. Now let's compare this thing here with this thing here, and the answer is all the variable stuff is pretty close. So as I showed you in the previous example, what we're going to do is I'm going to just get rid of the 5 for the moment. I'm going to consider the integral of x squared and start thinking about what do I need to do to the integral to make it the antiderivative of this. Okay, and what I'm going to do then is, okay, what I see is that 15 on 2, if I integrate that, or the antiderivative of that, is that. So what I want is a 15 on 2 here. Okay, so let's put that in there. Okay, now, but what I've done is I've introduced this thing, so I need to balance my expression here. So I'm going to invert and do that. So now what I've got is that thing there, 15 times on 2 times 2 on 15, that's just 1, and that still leaves me with the original expression, just written differently. But what I know is that this bit here can be found by that, and I've got some numbers out the front, which is fine. I can do that. Equals. Now, 5 divided by that, we cancel those and we get 1 on 3. So I have 2 on 3, so there's the numerical part. And we have, now it doesn't matter how you write it, but let's just go straight to where we began this whole question, which is x cubed minus 4 to the 5th and plus c. And there's the answer to the integral. So we're looking for the hence. Just, I suppose, by the way, you know, all these examples I've used so far have been indefinite integrals, but certainly I could put a value, you know, from 2 to 3, for example, in which case I would have to evaluate that, and I would not have a plus c. So, in summary, what's the method? Matching. Right, we're looking. The word hence tells us we're looking to match from the previous question. So when we and the problem will be that the 5 and the 15 on 2, these coefficients will not match. Bring it out the front and then introduce the correct coefficient from the previous part of the question. Make sure you put its inverse in there as well, and you can finish the question with as an antiderivative. Okay, good luck.